of receiving AC power at
Are
one
you getting
voltage
voice of
and
PC?
delivering it at another voltage.
Yes, sir.
Yes, sir.
Yes, sir.
In this way, they help achieve better transmission efficiency while transferring the power over longer distances. In this video, we will go through the working and construction of a three-phase transformer by starting from its simplest form. The basic working principle of a transformer is simple: electromagnetic induction. According to this principle, a varying magnetic flux associated with a loop will induce an electromotive force across it. Such a fluctuating magnetic field can easily be produced by a coil and an alternating EMF system. A current-carrying conductor produces a magnetic field around it. The magnetic field produced by a coil will be as shown in the figure. With the fluctuating nature of the alternating current, the magnetic field associated with the coil will also fluctuate. This magnetic flux can be effectively linked to a secondary winding with the help of a core made up of ferromagnetic material. This fluctuating magnetic field will induce an EMF in the secondary coils due to electromagnetic induction. Since the turns are arranged in a series, the net EMF induced across the winding will be the sum of the individual EMFs induced in each turn. Since the same magnetic flux is passing through the primary and secondary coils, the EMF per turn for both the primary and secondary coils will be the same. The EMF per turn for the primary coil is related to the applied input voltage as shown. As a result, the induced EMF at the secondary coil is expressed as follows. This simply means that with fewer turns in the secondary, but since energy is conserved, the primary and secondary currents have to obey the following relationship. Three-phase transformers use three such single-phase transformers, but with a slightly different coil configuration. Here, the primary and secondary coils sit concentrically. Two more such windings are employed in a three-phase transformer. Transformers with high power ratings generally employ a special kind of winding, known as a disc-type winding, where separate disc windings are connected in series through outer and inner crossovers. The low-voltage windings are connected in a delta configuration, and the high-voltage windings are connected in a star configuration. Thus, the line voltage further rises to root 3 times at high voltage side. This also means that, from a three-phase step-up transformer, we can draw 4 output wires, 3 phase power wires, and 1 neutral. High voltage insulated bushings are required to bring out the electrical energy. The core of the transformer is made of thin insulated steel laminations. Such steel laminations are stacked together as shown to form three-phase limbs. The purpose of thin laminations is to reduce energy loss due to eddy current formation. The low voltage windings usually sit near the core. Various kinds of energy loss happens while transferring power from the primary to secondary coil. All these energy losses are dissipated as heat. So usually the transformer is immersed in a cooling oil to dissipate the heat. The oil dissipates the heat via natural convection. Oil in the tank will expand as it absorbs the heat. A conservator tank helps to accommodate for this volume change. To know more on different types of transformer cores and windings, please check out our other videos. Thank you.
Innovations in cloud computing, blockchain, and IoT are creating a
Hello.
Yes, sir.
Okay.
Yes, sir.
So you got some insight regarding what is transformer?
Yes, sir.
Yes, sir.
It was nice animation done by someone, right? So can you see my screen?
Yes, sir.
Okay. So basically we will this unit, right? So let us start with this unit. The name of the unit is Unit 4 Single Phase Transformer. Okay. So we will be covering working principle, then how the construction of the transformer is done, what are the different types of transformer, then the transformer needs to be evaluated because there is voltage and current involved. So is there any equivalent circuit of that transformer? Then yes, there will be some losses in the transformer. And then transformer is having input and output, so we can see the efficiency and regulation of the transformer, right? So this is the syllabus, right? And for your uh, first year concern, right, only single phase transformer is important, correct? So we will concentrate on the single phase transformer, although in the video we have seen the animation of three phase transformer also. Okay, so what you can understand that transformer is nothing but, you can say, a device which converts energy into energy, right? But electrical energy into electrical energy. Then what is the use of it? So the use of it is it will change the voltage or current according to our requirements, correct? Yes.
Yes, sir.
Okay, okay. So transformer, it works on AC current, AC voltage. So that's why we can call it as AC device. Then voltage and current can be amplified or reduced. Then either it can be amplified, so we can call it a step up transformer. If it is reduced, we call it a step down transformer. है ना? So step up higher voltages level, step down lower voltages level. मतलब एक एग्जांपल देता हूँ मैं आपको, where we can use. So for example, हमारे हमारे पास जो इलेक्ट्रिसिटी आता है, सो वो कितना होता है, कितना वोल्ट्स होता है घर में आता है वो
220 to 240 volt.
एंड एमएसवी जो ट्रांसमिशन लाइंस रहते हैं वहां पर क्या कौन सा कितना वोल्ट्स रहता है, मे बी 1000 वोल्ट और 11
1000.
वोल्ट्स, राइट? तो ये वोल्ट को कम करना है हमें और फिर यूज करना है, तो इसीलिए हम क्या करेंगे, हम यहाँ पर
Step
स्टेप
down.
डाउन ट्रांसफार्मर करेंगे. ओके, कभी कभी क्या होता है ना कि हमारे घर में सोलर पैनल रहते हैं और फिर हम सोलर पैनल से भी इलेक्ट्रिसिटी दे सकते हैं ग्रिड को, तो फिर हमें रिवर्स वे में कन्वर्ट करना पड़ता है. सो दैट टाइम वी यूज स्टेप अप ट्रांसफार्मर. गेटिंग? सिंपल है.
Yes, sir.
Yes, sir.
So single phase transformer and three phase transformers are there. So symbol for the transformer is like this, right? So this is called as primary winding on the left hand side, right? This is called as your primary winding, this is called as your secondary winding. डिनोट ऐसे करते हैं, वन और ऊपर डिग्री लिख देंगे, primary winding, secondary winding. Okay, any problem in this? So this is the notation of the transformer. Okay, now working principle of the transformer. So what is, before that I will just tell you that how the transformer is made. So let us suppose that we are having a copper wire. तो ये ब्लू कलर से जो वायर है ये कॉपर वायर है, इसका वाइंडिंग है यहाँ पर, और ये जो स्क्वायर फ्रेम दिख रहा है दैट इज आयरन कोर फ्रेम. क्या बोलेंगे उसको? आयरन कोर फ्रेम. और उसके बाद में at the other end there is also another copper winding, right, and that is also iron core frame. तो देखिए यहाँ पर क्या हो रहा है, समझ में आ रहा है मैं क्या बोल रहा हूँ? गेटिंग? यहाँ पर लेटेस्ट से ये कौन सा साइड है? प्राइमरी सेकेंडरी. दिस वन इज प्राइमरी साइड, दिस वन इज सेकेंडरी साइड. हाँ बोलिए अभी इसमें क्या जा रहा है इनपुट? I1, राइट. सो प्राइमरी का जो करंट है, प्राइमरी जो में करंट फ्लो हो रहा है दैट वी कॉल इट एज I1. प्राइमरी में जो वोल्टेज है दैट वी कॉल इट एज V1. प्राइम सेकेंडरी का जो करंट है दैट वी कॉल इट एज I2. सेकेंडरी का जो वोल्टेज है दैट वी कॉल इट एज V2. समझ में आ रहा है मैं क्या बोल रहा हूँ? So
Yes,
these
sir.
are the notations which we will be using, right? I1 input current, I2 output current, then V1 input voltage, V2 output voltage. Okay. Now Faraday's law of electromagnetic induction क्या बोलता है? Whenever there is a current which is flowing in the coil, what will happen? Magnetic field will get developed, right? So there will be some magnetic lines which I can draw like this, right? So this magnetic lines will be there, and देखिए iron is a very good conductor of magnetic lines, correct? उसको हम मैग्नेटिक फ्लक्स बोलते हैं. ओके, सो व्हाट विल हैपन एज वी हैव इंट्रोड्यूस्ड द iron core here, what will happen? This magnetic lines will pass through this core, and what will happen? This will pass through the core, and then what happens whenever there are magnetic lines, right? What will happen? Current will get induced in this secondary coil. So according to Faraday's law of electromagnetic induction, what we are getting? We are getting the voltage and current present. Getting? So this is basically the working principle of the transformer. So like this, if voltage, if I'm getting the current at the secondary, then what will happen? We can get the voltage at across the secondary coils. Yes.
Yes.
So who is responsible for transferring the voltage? Magnetic flux. Yes. Now, what
So
happens, you know?
why
Yes.
why we are using copper wires are there in
Yeah,
coil?
because copper is very good conductor of electricity. है ना?
Okay, sir.
Normally we can use gold wire also, but it is very costly, you know? Silver, copper. So the better and cheapest material which we use for conduction is copper, you know? Any wire you would see, we have copper wires, right? In our homes also, if you see, for transmission of electricity, we use copper wires. Okay.
Okay, sir.
Okay. Now, you know, so there is some EMF which is getting induced at the primary. So let us call it as V1, and there is some EMF which is induced in the secondary. Let us call it as V2. Now, that depends on the number of windings at the primary and secondary, right? So these are nothing but, you can say, this is winding. So इसमें कितने turns होंगे? So let us say N1 are nothing but the turns at the primary side, and N2 are nothing but number of turns at the secondary side. So this V2 by V1 is proportional or is equal into N2 by N1. Okay, and we know that there is no power change, right? Power in the input is equal to power in the output. So we know power is nothing but V into I, and again I can write P2 is nothing but V2 into I2. So from this I can write it as I1 by I2 is equal to V2 by V1, and then I can write this equation. Can I say this? V2 by V1 is equal to N2 by N1, and V2 by V1 is equal to I1 by I2, correct? Yes, no?
Yes,
Yes,
sir.
sir.
Okay, let someone is in the meeting. I will just allow him. Okay. So this is called as transformer equation. क्या बोलेंगे इसको? Transformer equation. Getting? Simple है. देखिए V1 by V2 is equal to N1 by N2 and equal to I2 by I1. करंट सिर्फ उल्टा रहता है. ओके. नाउ जो V1 है आपका, so that is nothing but the RMS voltage. ओके. बट किसका? So induce हो रहा है ना voltage because of flow, because as the current is flowing, the EMF will get induced. So what is the EMF which is getting induced? So it is according to the formula 4.44 N1 F into phi m. What is F? F is nothing but the frequency. And what is phi m? Phi m is nothing but the magnetic flux. Yes? Density.
Yes, sir.
Yes, no?
Yes, sir.
Okay. Now,
Yes, sir.
RMS value at the secondary side, it will be 4.44 into number of windings at secondary side is N2. Frequency will be same and flux density will be same, correct?
Yes,
Right?
sir.
Yes.
Yes, sir.
So actually the formula is 1.11 into 4 phi fm, 4 f phi m, right? So it is for one turn, but as we are having number of turns, so we have to multiply it by n. Yes. So this is called as EMF equation of the transformer. Okay. Now let us solve a very simple problem. Okay. A single phase transformer with 50 hertz. What is given? Frequency. Correct. Has maximum flux in core as 0.021 Weber. Means what is given?
Flux density.
Phi m. And then is being number of primary terms are 460. Means what is given?
N1,
N1. And secondary is 52. What is given?
N2.
N2. Step up transformer, step down transformer.
Step down, sir.
स्टेप डाउन. वेरी गुड,
स्टेप
वेरी
डाउन
गुड,
सर.
वेरी गुड, वेरी गुड. देखिए कैसे पता चला मुझे. हमें पता है V1 by V2 is equal to N1 by N2. ओके. तो N1 का वोल्टेज, N1 टर्न्स N1 में ज्यादा है या N2 में ज्यादा है?
N2.
N2 में कम है.
N1.
N1 में ज्यादा है. मतलब प्राइमरी में ज्यादा टर्न है तो वोल्टेज भी ज्यादा रहेगा. सेकेंडरी में कम टर्न है तो वोल्टेज भी कम रहेगा. तो प्राइमरी का वोल्टेज ज्यादा, सेकेंडरी का वोल्टेज कम. मतलब इनपुट ज्यादा, आउटपुट कम. कौन सा ट्रांसफॉर्मर? स्टेप डाउन ट्रांसफॉर्मर. ओके. सो यस, calculate the EMF induced in primary and secondary, right? So can you calculate it?
Yes, sir.
What is the formula? मतलब what you want to find? You want to find E1, you want to find E1 and
E2.
E1 and E2, right? So E1, formula for E1 is 4.44 into N1
N1 into frequency,
into frequency into
flux
phi.
density.
You know FM, you know phi, F, phi m, and all that, right? So can you so find the value of E1 and E2? Yes.
Yes.
Okay.
Yes,
Yes,
sir.
sir.
Okay. Now let us say a single. Let us solve second problem, right? Or shall I give you the solution? So this is okay. We'll just have second problem. Okay. A single phase transformer of 50 hertz. What is this? Sorry. What is given? What is this 50 hertz?
Frequency.
Again, it is
Frequency.
right. 300 primary terms. What is given?
N1.
N1.
N1,
750 secondary terms. What is given?
N2, N2,
The net cross section area of the core is 64 square centimeter. Means what is given?
Area.
Area. If the primary induced EMF is 440 volts, means what is given?
E.
E1.
E1. Very good. Okay. Find maximum flux density. What we have to find? Phi m.
Flux M.
Correct?
Yes, sir.
Okay. So what is given here? See, in this formula, N1, we have N1, we have frequency, we have E1. Can we find phi m?
Yes, sir.
Yes, and maximum flux density can we find? Yes or no?
Yes.
Yes, sir.
Calculate the induced EMF at secondary of the winding. You can use the same formula. Once you know phi m, you can calculate E2. Yes?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. Now, third, again, similar problem is there. Very, very same problem is there. Just the difference is a 250 kVA. A 250 kVA. What is given this? This is nothing but P1, right? It is equal to V1 into I1, and this is 250 kVA. Correct? 250K.
Yes, sir.
K means what? 250 000. Okay. Now, what is this? 1100, 400. What is this 1100? V1. What is this 400? V2. लिखने का तरीका बता रहा हूं मैं आपको. Yes.
Yes, sir.
Yes, sir.
50 hertz means what is given? Frequency. Transformer has 80 turns on secondary means what is given? N2. Can we find the approximate values of primary and secondary current? Right? Means what is asked? They are asking what is I1 and what is I2. Can you calculate? Now,
Yes, sir.
see what is given. What is given? See, E1 is equal to 4.44 F into N 1 into 5m, right? So what is given? E1 is given. Yes. 4.44 F is given. N1 is given.
Yes. No, sir.
No. N2
And
is
one is
given.
not.
N1 is not given. Okay. Before that, P. Can I say V1 is given?
Yes, sir. We can
V1
calculate.
is how much?
Uh,
11000.
11000.
So can we calculate I1? I1 is what? 250000 divided by 1 1 1 2 3. Correct?
Yes, sir.
Yes. So this
Yes,
is
sir.
I1. Okay. And similarly, can I write law of conservation of energy? P2 is equal to
V2
V2
I2.
into I2. V2 is given
Yes, sir.
400 volts. So can we calculate I2?
Yes,
Yes.
sir.
Yes, no.
Yes.
So P2 का value पता है, V2 का value पता है. So we can calculate I2. So please calculate. So first part is over. Second, approximate number of primary turns. N1 चाहिए ना हमें?
So V1 upon V2 is equal to N1 upon N2.
Correct. Very good. V1 upon V2 is equal to N1 upon N2. Right? इससे हमें क्या मिलेगा? We can get N1. Right? From this. Because we know V1, we know V2, we know N2. Yes, it's very simple. Correct?
Yes, sir.
And once we get N1 also, we can calculate maximum value of the flux. Phi m. Phi m is maximum value of the flux. And flux density क्या है? Phi m divided by area. Correct?
Yes, sir.
Easy है?
Yes, sir.
Any problem?
No, sir.
No, sir.
Okay. So I hope these are simple questions and you can just solve it. Okay. So I'm expecting all the answers from this. Okay. Okay. Now let us go to the next part called as construction of the transformer. Okay. तो ट्रांसफॉर्मर बनता कैसा है वो भी हमें पता रहना चाहिए ना, है ना? So the simple two winding transformer consists of each winding being wounded on the separate soft iron link, right, or core, which provides the necessary magnetic circuit. Now, so this I can show you. So what is in the construction of the transformer? So this is iron core. क्या बोलेंगे इसको हम? ये जो फ्रेम है ना, मैं हाईलाइट करता हूँ. ओके, ये जो ग्रीन कलर के हाईलाइटेड फ्रेम है स्क्वायर वाली, करेक्ट? दिख रहा है ना आपको?
Yes, sir.
Okay, so this green color highlighted frame is called as iron core. क्या बोलेंगे इसको? Iron core. And then there are two windings. So this is called as your primary winding. This is called as your secondary winding. Yes.
Yes,
Okay.
sir.
Now this core can be like this also, right? Instead of keeping a simple like this core, what I will do, see, हमें क्या चाहिए, flux linkage करवाना है, so flux linkage मैं इस तरीके से भी करवा सकता हूँ. So depending on the shape of the core, I can classify the transformer as core type transformer. This is core type transformer and this is shell type transformer. जो आयन का जो आपका प्लेट है वो किस प्रकार से है, right? So depending on that, we can call it as core type transformer or we can call it as shell type transformer. Any problem in this? And of course, in both
No.
the types of the transformer, what will be there? There will be primary winding and secondary winding, right? So in both the cases, the principle works, principle is same, right? Now what happens, जो core है, okay, either it is core or shell, right? So जो core है वो एक पूरा आयन का रॉड रहता है क्या, एक आयन का पूरा फ्रेम रहेगा? So no, it is the frame is made up of stamping. Stamping मतलब क्या कि एक एक आपने स्लाइस ले लिया, राइट? स्टील का एक स्क्वायर स्लाइस ले लिया और ऐसे काफी सारे स्लाइस है ना, एक के ऊपर एक रख दिए, बट ईच एंड एवरी स्लाइस इज इंसुलेटेड. समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
तो इसको बोलेंगे सिंगल लैमिनेशन. क्या बोलेंगे? सिंगल लैमिनेशन. तो एक हमने स्क्वायर फ्रेम का लेटस से एक मतलब एकदम पतला सा एक स्क्वायर फ्रेम बना लिया, उसको हमने लैमिनेट कर दिया प्लास्टिक से, और ऐसे हमने काफी सारे लैमिनेशंस लिए और उनको मर्ज कर दिया, मतलब उनको सब एक के ऊपर एक रख दिया, एंड देन दैट कोर इज बीइंग कंस्ट्रक्टेड. समझ में आ रहा है?
Yes, sir.
And typically each laminate is 0.35 to 7 mm thick, मतलब 1 सेंटीमीटर से भी कम. इतने पतले पतले आपके स्लाइसेस रहेंगे. Then why we are doing like this? Yes, anyone? ऐसे स्लाइसेस क्यों करेंगे हम लोग? बोलिए.
For transfer of heat, sir.
For
Transfer of heat.
heat. Okay. 20% you are correct. Okay. और कोई? ओके, चलिए मैं आपको बताता हूँ कि मैंने क्या किया पता है. इंस्टेड ऑफ दिस आई हैव यूज्ड अ रॉड और उसके ऊपर वाइंडिंग कर लिया. ट्रांसफॉर्मेशन का काम करेगा, 100% करेगा. लेकिन अगर आपने 5 मिनट ट्रांसफार्मर को चालू रखा और फिर वो रॉड को टेम्परेचर चेक किया, तो व्हाट विल हैपन, द रॉड विल गेट heated up. Okay, and when the rod will get heated up, it will melt the windings and your transformer may get damaged. Second thing, if the rod is getting heated, means what? Why it is getting heated? Okay, if it is getting heated means what? Your energy is getting lost, right? The electrical energy is being converted into heat. Yes.
Yes, sir.
So that is
Yes.
loss. That is the loss. And why it is getting heated? It is getting due to, whenever you have seen a term in physics called as eddy currents. एडी करंट ऐसे बोलते हैं, right?
Yes, sir. Addy.
So
Correct.
so what are these currents, right? Whenever a magnetic line is passing through a ion, what will happen? It will form the currents, right, which are circular in shape, and then that current will indirectly it will heat up the material, right? So that eddy currents that are proportional to the thickness of the conductor, right, or thickness, right? So what is happening, that thickness, okay. Hello.
Yes, sir.
So to reduce that thickness, what we are doing, we will.
Sir, your voice is low, sir. We can't hear you.
Hello. Am I
No,
audible
sir.
properly?
Yes, sir. Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Okay. So please increase the volume at your end. Okay. Yes. So the thing is that instead of using a very high thick conductor or very high thick what we can say rod, we are using a single laminated things, and then we are stamping each other, right? Okay, so this is the construction of the core, what I can say. And then shell type is also the same thing, right? We are using various laminates, but the shape will be different in this case. Okay, so you know the what we can say, this individual laminate are stamped out, right, of larger steel sheets, and it may be of various shapes, right? It may be E shape, L shape, U shape, I shape, as shown below, and then उनको आप ज्वाइन कर सकते हो. ओके, So comparison for comparison purpose, right? So core types, your winding encircle the core, right? दोनों अलग अलग opposite end पे winding रहेंगे आपके. Single magnetic circuit is there. बराबर है, एक ही magnetic loop रहेगा ना, है ना? Yes, no?
Yes, sir.
हाँ, और यहाँ पर दो मैग्नेटिक लूप रहेंगे. उसके बाद में कोर हैज टू लिम्स. ओके, मतलब कितने वाइंडिंग्स है, कितने लिम्स है? टू
2.
लिम्स यहाँ पर, है ना? एक और दो. यहाँ पर कितने लिम्स है? एक,
1.
दो, तीन. ओके, यहाँ पर सिंगल सर्किट बन रहा है, यहाँ पर एक सर्किट ये और एक सर्किट ये, ऐसे दो सर्किट्स बन रहे हैं, राइट? देन cylindrical coils are used here. Sandwich types coils are used. Sandwich type मतलब क्या? We can wind the coils one above another. Okay, then coils can be easily removed for maintenance. Here removal of coils very danger, right? मीन्स अगर फिर से वाइंडिंग करना है तो बहुत मुश्किल काम है. ओके, इट इज यूज्ड फॉर लो ट्रांसफॉर्मेशन, इट इज यूज्ड फॉर हाई वोल्टेज ट्रांसफॉर्मेशन. Okay, so this is the depending on some applications, right? We are using core type or shell type. So whenever you want to play with low voltages, you will go for core type. Whenever you want to play with high voltages, you will go for shell type. Okay, so basically, depending on now this two classifications, core type and shell type, that was depending on the shape of the you can say the iron core, okay, or shell. Now depending on the type, depending on what voltage it is giving at the output, we can classify the transformer into three types. दो तो मैंने बता दिया आपको, स्टेप अप और स्टेप डाउन. आइसोलेशन क्या होगा बताइए? either step up nor step down, correct? So isolation transformer, सुनिए, step up. Okay, now I can just tell you logically as well as mathematically. बोलिए, step up में वोल्टेज लेवल कैसे रहेगा? V1 V2 का कंपैरिजन बताइए, कौन बड़ा रहेगा?
V2 is greater than V1.
स्टेप डाउन में कौन बड़ा रहेगा?
Step
V1.
down में V1.
1 बड़ा रहेगा.
स्टेप
Step
अप
up
में?
में V2.
V2 बड़ा.
V2.
आइसोलेशन में?
इक्वल.
Equal होगा.
Correct. Then why we need isolation transformers if the voltage is same? Why we need isolation transformers? So step down transformer, let us see. Okay, so step down transformer में what will happen? The higher voltages, primary voltage will be at high level and secondary voltage will be stepped down. For example, कहाँ पर use होता है ये? देखा था हमने रेक्टिफायर में, है ना? चार्जर में, आपके मोबाइल के चार्जर में, आपके मोबाइल में चार्जर में आउटपुट में चाहिए 5 वोल्ट्स और इनपुट में दे रहे वो 230 वोल्ट्स. सो विच ट्रांसफार्मर वी वांट? स्टेप डाउन ट्रांसफार्मर, करेक्ट?
Yes, sir.
Yes, sir.
Okay, so n1 to n2 will always be equal n1 by n2. इसको क्या बोलेंगे आप? वाइंडिंग रेशियो और ट्रांसफार्मर रेशियो. so n1 by n2 will always be greater than 1. yes, n1 के वाइंडिंग हमेशा ज्यादा ही रहेंगे, है ना?
Yes, sir.
Okay, then second is your step up transformer. Step up transformer exactly opposite of step down transformer. Here the primary to secondary winding will always be less than 1, correct? Yes, no?
Yes, sir.
Yes, sir.
And third one is the isolation transformer, right? So isolation transformer does not convert the voltage level. So the primary voltage and secondary voltage are same. So number of primary terms is equal to number of secondary terms. Hence the ratio is equal to 1. Right? इसमें जितना n1 है उतना ही n2 है. n1 is equal to n2, correct?
Yes, sir.
है ना?
Yes, sir.
Yes, sir.
तो फिर बोलो. This is because why we are using this transformer? So it is used for safety purpose or to cancel the noise transfer from primary to secondary. समझ में आ रहा है? मतलब मुझे दो सर्किट को तो कनेक्ट करना है. मतलब पहले सर्किट से मुझे 50 वोल्ट लेना है और दूसरे सर्किट को भी 50 वोल्ट ही देना है. लेकिन दोनों सर्किट को इलेक्ट्रिकली कनेक्ट नहीं करना है. तो क्या करेंगे हम? यूज ट्रांसफार्मर. कौन सा? आइसोलेशन ट्रांसफार्मर. सो इफ आई वांट टू कनेक्ट टू सर्किट्स विदाउट इलेक्ट्रिक कनेक्शन, right, direct electric connection, then we can use this isolation type of transformer, right? Also, it will prevent the noise from transferring from primary side to secondary side. Okay. Yes.
Yes, sir.
Yes, sir.
Now, depending on the material used for the construction of the core, we can classify the transformers like iron core transformer, right? So here we are using iron as a soft iron material, right, for construction of the core, right? All iron ferrite, these are nothing but conductors of magnetic field, right? So if you are using ferrite core, if you are using ferrite material in the construction of the core, then we call it as ferrite core transformer. It is why we are using ferrite, due to its high magnetic permeability. What is permeability? Permission, right? What is permeability? Ability to allow the magnetic flux to flow through it. समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
Okay. Then third is your third, okay, fourth लिखा है लेकिन third is your air core transformer. कुछ भी नहीं है, हवा में से भी magnetic lines जाएंगे ना, right? So when air is used as a core medium, right, for transfer of magnetic flux or for linkage for the magnetic flux, then we call it as air core transformer, right? So normally these are the types of the transformer depending on the material used for construction of the core. Okay. Again, we can classify the transformer into three types. For what purpose it is used, right? For transferring the power, we use power transformer, right? So power transformer are used in high power transfer application, right? जैसे पिक्चर में दिख रहा है आपको, right? Okay. So if you want to transfer the power, okay, if you want to transfer the power from one city to another city, then we use power transformer. Yes, no?
Yes, sir.
ओके नाउ सेकंड इज मेजरमेंट ट्रांसफार्मर. मेजरमेंट ट्रांसफार्मर मतलब क्या? देखिए, आपको अगर जो आपका एमएसबी का लाइन है, हाई वोल्टेज लाइंस, उसमें वोल्टेज कितना है? अभी अभी देखिए कितना वोल्टेज है, 33 किलो वोल्ट्स, राइट? 33 किलो वोल्ट्स अगर आपको मेजर करना है कि सही में 33 किलो वोल्ट्स है, तो कैसे मेजर करेंगे आप बोलिए मुझे? यू विल गो विथ मल्टीमीटर,
मल्टीमीटर.
देन यू
No,
विल,
sir. It will
हाँ
not work there.
हाँ, तो मल्टीमीटर को अगर लगाएंगे ना, तो मल्टीमीटर
उड़
के
जाएंगे.
में क्या होगा?
पता ही नहीं चलेगा उसका.
हाँ, मल्टीमीटर के साथ में,
हम भी उड़ जाए.
हाँ, तो दैट्स वाई हमें कुछ तो भी सेफर तरीका चाहिए. तो हम क्या करेंगे पता है? हम स्टेप डाउन ट्रांसफार्मर यूज करेंगे. वो 33,000 वोल्ट्स को 33 वोल्ट्स में करेंगे और फिर मल्टीमीटर यूज करेंगे. समझ में आ रहा है? तो जो ट्रांसफार्मर है ना, जो ट्रांसफार्मर मेजरमेंट पर्पस के लिए यूज हो रहा है ना, उसको हम मेजरमेंट ट्रांसफार्मर बोलते हैं. मतलब देखिए, ग्रीन कलर वाला क्या कर रहा है पता है? जो अपने हाई वोल्टेज लाइंस है ना, वो उसके प्राइमरी में जा रहे हैं, सेकेंडरी में यहाँ पर कहीं पे तो भी बाहर आउटपुट निकला होगा, एंड देन दैट सेकेंडरी वाइंडिंग is we will measure the voltage, and as we know the turns of the transformer, we can calculate, okay, फिर वो 33, अगर रीडिंग 33 आया आउटपुट में, तो उधर 33,000 किलो वोल्ट्स होगा, राइट?
Yes, sir.
हाँ, so like that we can measure. So that's why we call it as measurement transformer. And third is the distribution transformer, which we always see, right, for when the current is coming, okay, from MSB, and when we want to use it for household purposes, right? At that time we can use this distribution type of transformers. Yes.
Yes, sir.
Now डिपेंडिंग ऑन द सप्लाई, ओके, तो आपके सिलेबस में सिर्फ सिंगल फेज ट्रांसफार्मर है, बट डिपेंडिंग ऑन हाउ मेनी फेजेस इट इज वर्किंग, राइट, it is also classified as single phase and three phase transformer. Yes, any problem in this?
No,
No.
sir.
No.
So to summarize this, we can call it as core type transformer and shell type transformer, right? Then three types: power transformer, measurement transformer, distribution transformer, air ferrite and iron core transformer, step up, step down, and isolation transformer. Correct?
Yes, sir.
Yes,
Yes.
sir.
Simple है?
Yes, sir.
Yes, sir.
So that's it. If any difficulties from your side, you may ask me. Else, okay, I will stop recording. And if there are any difficulties, we may discuss it out. Okay.